Hello friends, I am Sanchit Mehra and today I would be explaining you about an STL in C++ which is a set. So set is a kind of a container in which you can contain only the unique elements. You can only store the keys and the keys and values both are the same, and it's sort of a unique element, constant element that you store it as in a set that has to be immutable. That means you cannot change the value of that key once you insert it because it is getting inserted as a key. So it has a unique elements first, then it's a sorted. Okay, so once you insert the elements in a set, it gets sorted whether in an ascending order or a descending order depending upon the way you declare your set. Okay, so by default the elements are stored in an ascending order, but if you want to get all your elements get stored in a set in a descending order, you have to give that one when you are declaring the set basically. Okay, so we'll come to this thing as well. Now the third point is the elements are immutable. That means the keys that you cannot change it, and which is quite obvious that you can't change the keys, because once you change the keys you disturb the order and you can't change the element once you insert that into a set. So that has to be a constant element basically, and they are not indexed. That means as we see in vectors that elements they are indexed, and so you can access those elements by indexing, but you can't do it that in set. Though in set they are sorted, and we internally it uses the binary search tree to maintain the sortedness of all the elements, whether in descending or ascending. We'll come to that later. And so binary search tree always give you the insertion deletion searching in order complexity is of log of n, since it's a binary search tree, and using the red black technique, it makes sure that your binary search tree is always balanced, so that it always gives you the log of n complexity. Okay, so that's all about the theory. So let's begin about some practical things. So before that, we'll include the header here, and here I'll include the set, and to declare my set I'll use set, and in this templatized parameter I'll pass the int here, and let me do it as my set here. Okay, so this is I'm declaring the empty set here. Okay, and I can use its method called its insert to insert the elements. Okay, so my set insert, and let's say insert the value 10. Yeah, and then I go on inserting some numbers. Yeah, so let me take it as 4, let me take it as 30, and let me take it as 4 again. Okay, so what I'm doing is that I'm inserting all the elements in a random order, and I'm inserting a duplicate element as well. Okay, you see here I'm inserting 4 and 10, 30, and then I'm inserting the 4. So it's quite of random order. Okay, so let's try to iterate over the set, and let's see in what order are they being inserted. Okay, so for that we'll use the we'll get the iterator. So set integer the iterator, and let's first declare this iterator, and in the for loop I'll have this iterator equal to my set dot begin. Yeah, so this method begin, it returns an iterator that points to the first element that the my set would be having. Okay, so we'll initialize our this variable to point to the first element basically, and we'll go on iterating until I get an iterator which is equal to the iterator returned by the end method. So this end method returns an iterator which is the a kind of a iterator which is pointing to the point which is beyond the last element. Okay, so it's kind of an iterator that does not belong to any valid element inside the set, and when you get that iterator, that's the time we need to remove this loop because it doesn't point to a valid element. Okay, and we just go on incrementing our iterator till we reach the end of the till we get the iterator, which is by the written by this end method. Okay, so we'll just have the iterator, we just dereference it, and let's see. Yeah, so let's compile it and run it, and let's see. Okay, let me run it. So yeah, we see here that first we get as 4, so the first element the begin returned is 4 here, and then the 10 and the 30. Okay, so 4, why? Because the elements are sorted in a sorted order. It's the default sorting is ascending order, that's why we got as 4, 10 and 30. I inserted 4 again, but it does not get inserted successfully. Why? Because all the elements are unique elements that has to be in a set, and so the set data structure is so much helpful, in which we want to know whether the element is already present or not present. So we employ my set in such kind of problems. Okay, so now if you want to insert those elements in a descending order, okay, then you can or there are two ways basically. First, if I want to print this elements in an ascending order, and I want my elements to remain sorted in an ascending order in my set. Okay, so what we will do is that we will have a reverse iterator here. Okay, and we will have the R begin here, and we will have the R end here. Okay, so we'll reverse this iteration. Okay, the elements are still sorted in my set container, it's 4, 10, 30, but I'm printing it in reverse order now. So let me run it. Now you see it's printed as 30, 10 and 4, right? So that's the reverse iteration. It's how we do the reverse thing. So I'll just undo the reverse iteration, and now we can just run it, and we see that it's printed as 4, 10 and 30. Now the thing is, I want to insert, I want the sortedness to be descending order. I want all elements to be sorted in my in my set container. So what I can do is that I can have this parameter here, which is std greater, and since it's int here, so I'll use the int. So I'll just need to pass this std greater with integer as the data type, because it will compare to integers. So now when you are inserting it, this will let those elements get inserted in a descending order. Okay, so when you do that now, compile, you will see that we get the 30 first, 10 and then 4. Okay, so this is how you maintain the order, whether you want ascending order or descending order. And if you want to have a descending order, you can give this templatized parameter to the set. Okay, now there are always not mechanisms, there is other mechanisms also in initializing my set. Let's see what all parameters we have. So let me comment this. So you could also initialize it here using an initializer list, which is you have from C ++11. So you can have 10, 4, 30, 4. Okay, so this would do you the same thing basically. Okay, so if you run it, so now you see that I have the same output, 30, 10 and 4. I use the initializer list to initialize my set. Okay, whereas previously I was initializing an empty set, where here I'm initializing with the initializer, which is a C ++11 concept. Okay, now there is a third way also, in which you already have some iterable data structure. For example, you have an array, let's say array, you have 4 here, and you have 10, 4, 30, 4 here. Okay, so what you have to do is that you just need to pass the ARR, and this ARR plus 1, 2, 3, 4 elements are there, so ARR plus 4. So you have that's called the range constructor, in which you are passing the range from begin and to the end. Okay, So that would also give you the same output here. Okay, so let me compile it. So you see that your my set is getting initialized, and it is with this range constructor, and 30, 10 and 4 is the same output that you're getting. Okay, so now friends, your task would be to initialize your set using the copy constructor, okay, or the move constructor. That's your homework. Okay, take it and let me know how you can initialize it with the copy constructor. Okay, so I'll leave that with you. So these are the basic 3 ways by which you can initialize your set. All right, so now let's say if you want to find some element, okay, or let's say you want to first find the size of your set. What's the size? So you have this function, size of my set equals to, you have my set dot size here. Okay, and if you will run it, you will get the size, which would be 3. Okay, so my size of my set is 3. Now the thing is, if you want to find an element here, okay, how would you find an element? So there is a function my set dot find, and you have to give what element you want to find. Let's say I want to find the element 30 here. Okay, now it will return me an iterator to it. Okay, so let's me take it as iterator. Let me name it as iterator or found iterator. Okay, so it will return me an iterator. So now if it finds the element 30 inside my set, it will return an iterator that points to that element 30. Okay, so you can print it std cout element found, and you could just do it like this here. So this found iterator would be pointing to the element 30 inside the set, and when you dereference it, it will give you the value. Okay, so let me run it. So now see, it says element found and 30, I mean the iterator, it is dereferencing it and it's giving you the value 30 here. Okay, but what if the element does not exist in my set? Let's say it is 300. Okay, and if I run it, let's see what happens. Yeah, so it gives you elements found 0. Why? Because it returns, again it returns an iterator, but it returns an iterator that does not point to a valid element. So it returns an iterator which is the same as the iterator written by the end method. Okay, so we can do it as if found iterator is equal to my set dot end std element not found. Okay, and let me name the element here. Which is, let's say 300, or let me simply have this element not found. That's simple. Okay, and in the else part we have found the element, since it's a valid iterator and it's not an invalid iterator. So now let me run it again. So you see here element not found is there. Why? Because the iterator that is written now, it is an invalid iterator, because we do not have any element 300 here in my set here. Okay, so it returns an iterator which is same as the iterator written by end method, and so we know whether that element exists in my set or not. Okay, so that is the thing here. Now the last thing is when you want to, so we cover up the insertion, we cover up the lookup, which is the find, and now next thing is you want to erase something or some elements from a set. So let's say you want to erase an element. Okay, so we have the method here, my set dot erase here. Okay, so there are three things. You can pass the iterator, you can pass the key itself, and you can pass the range of the iterator as well. Okay, so let's say I want to pass an iterator here. Okay, so let me see. So let me have this 30 here. So it will return me a valid iterator found, and later I would be deleting the same iterator here. Okay, sorry, no, I will be deleting the value which is being pointed to by this found iterator here. Okay, and then I'll just copy paste this code to print all the elements here. Elements after deletion. Okay, so I'm now deleting this. I would delete this 30 here by this method erase, and I have passed it to an iterator basically. Okay, so let's see. So yeah, so elements after deletion. So firstly we have 30, 10 and 4. Now I get an iterator to 30 here, I get an iterator to a 30 here, and then I pass this iterator to this erase method, and it deletes the 30 inside the set, and then I have only the 10 and 4 remaining. Okay, I have only the 10 and 4 remaining. But now if I give and so now this 3, if I find this 300, it would give me an iterator which is not a valid iterator. And what would happen if I pass this inside this erase methods? Okay, because it doesn't point to any element inside that inside this you could say the valid element in a set. So let me run it. Yeah, so you see that it crashes now. Okay, so we have to make sure that your whatever you are erasing, it should be a valid iterator. If you do not give it a valid iterator, your program would crash. Okay, so you should have this kind of a check basically whether the iterator is valid or not. Okay, so now you could straight away give the values also. Like if I give it at 30 here, the instead of giving an iterator, I give it the value straightforward. So now if I run it again, now you see again elements after deletion is 10 and 4, the 30 is again deleted. What if I give 3000, which is the number which does not exist in a set? Now let's run it and see. Yeah, so you see that it does nothing. Okay, because but when you give an invalid iterator, it would crash. Okay, now we have learned about the two ways of erasing. There is one other way, which is erase, which is the third type. Okay, so you could give the range of iterator. Okay, so let's say if I give the complete range, let's say my set dot begin, and which is my set dot end. Okay, so I hope it will clear my all the elements in an array, because I'm giving the complete range here. Okay, so let's see. Yeah, so element after deletion, there are no elements because I completely deleted the complete array here. Okay, so friends, this is all a short demo, a short working of my of how the set in STL works in C++. I hope you enjoyed these things, and if you like that my video, please like, share, and do subscribe for such knowledgeable videos that I post frequently on technology, C++, and data structures, algorithms. So thank you so much for staying here, and that's all for my side. Thank you. Bye bye. Take care.